as a logarithmic one? Well, we start out, I know that's the base. So this would be log base 4 of something equals something. And remember that the logarithm will pick up the range value, which is 16, and return it to the domain value, which is 2. Range value is 16. It comes back to 2. Because remember, the exponential, this guy right here, this is domain, this is range, and b to the x, the exponential function's going from the domain to the range. So when I rewrite it as a logarithm, it's picking up range values and bringing it back to domain values. So I'm going in this direction when I rewrite it. This says that log base, and that's the easy part, base A, of something equals something. Well, the base is A. It picks up the range value, which is 2.1, returns it to the domain value, which is 3. Log base something equals something. Well, the base is the easy part. The base is E. It's going to pick up the range value, which is M, and return it to the domain value, which is 2.2. Now, we haven't talked about this really, but you saw this in intermediate algebra. Anybody remember what log base E is? Natural log. So this is ln of M equals 2.2. If you wanted to keep it as log base E, that's fine. But when you work with it, your calculator, it's on your calculator, that logarithm. So you're going to have to be able to recognize it is natural log. And now the easy ones. Rewrite an exponential notation. So for me, 3 raised to the negative 2 power equals 1/9. B to the 2 equals 4. We said the base on the natural log is what? E. So this is log base E, that's natural log of x, equals 4. Or e to the 4 equals x. I've just solved the logarithmic equation because I can calculate e to the 4 in my calculator. Yay! I've solved my first logarithmic equation. Now how cool is that? Why am I the only one who thinks this stuff is cool? It's cool, it's fun, it's wonderful. Except for what we're about to do. I love this. That's what I love about college algebra. I just love college algebra. Probably my favorite subject. It really is. Domain of the logarithm. Now, let's see, what do we remember? Probably not much, but domain and range. Domain, all real numbers. Range is 0 to infinity. If I'm going to be looking at the exponential function, b to the x picks up numbers in the domain, which is all real numbers, takes it to 0 to infinity in the range. And what it comes back, log base b, picks up 0 to infinity and takes it back to all real numbers. Now what this means, the domain of the logarithm, of the basic logarithm of y equals log base b of x. Now by the way, this is a basic. and by the way, what I'm taking the logarithm of has a name, and it's called the argument. The argument of log base b must be greater than 0. In this case, x must be greater than 0 because that's what the argument is. But the argument can be things other than that, as you're going to soon see. It says what I'm taking the logarithm of must be positive. So what does that mean to me? Means to me, domain is all real numbers except 1. Denominator can't be 0. 2. Radicand must be greater than or equal to 0 for even index. And the last one, 3, the argument must be positive for the log. There are 3 things we have to concern ourselves with when we're finding the domain, and that also means no denominator, no radical, no logarithm. What's the domain? All real numbers, because it's all real numbers except. And if I have none of those 3, then the domain is all real numbers. So this is now the big guy. And if there's anything, you're going to be allowed a 3x5 index card on your final. If there's anything that you want to write on that card for your final, it's this. So here we go. Find the domain of each function. G of x equals the natural log of x minus 1. The argument, because it's a logarithm, must be positive. In this case, the argument is what you're taking the log of, is what's in parentheses, is x minus 1. That must be positive. X must be greater than 1. So that's what the domain of G is. X is going to be greater than 1. The argument has to be positive. Now the fun begins. I see there's a logarithm, and I want to find the domain. The argument must be positive. The argument in this instance is x squared minus 1 must be positive. How do I solve that?
Take that 1 over to the other side and square root.
Too soon. Factor it. Too soon. It is a polynomial inequality. And how have we solved polynomial inequalities?
Replace the inequality with the equal sign.
Replace the inequality with the equal sign. And we know this is going to be an open dot because we have strictly greater than. So I want essentially y positive but not equal to 0. So that x squared minus 1 equals 0. Now I can factor x minus 1 times x plus 1 equals 0. X equals 1. X equals negative 1. Now I would go to the not equal, but if I take a look at x squared minus 1, it's a polynomial. There's no denominator, there's no radical, I don't have any domain restrictions. And then we move to the number line. And they're all open dots. That's -1, that's 1. They're multiplicity 1, so everybody changes sign. Pull a test point. I can pull my favorite. And if x equals 0, I've got negative, change positive, change positive. I want positive. So in this case, the domain of G is minus infinity, -1, union, well, -1, 1, union, 1, infinity. Or you could say all real numbers, x can't be, oh, that's not true. That's a lie from the pit. There we go. Skip that. Because the middle thing is minus. I only want pluses.